Hello everyone, so we are starting a new thing. It's just continuing on with chapter 8. So I called it chapter 8.5. So we have solved quadratics. So today we are going to learn how to graph a quadratic. So our learning target is I can graph quadratic functions. And we're just going to start off with this parent function. That's what we call these when it's just the most basic function that you can have. We call that the parent function. So that is what we're going to be using today just during this intro part. And then we're going to get into some more detailed quadratic functions. So again, we call this the parent function. So I have linked the copy of these notes down below in your assignment tab in the module, whatever module you might be in. So if you want to print them off, you can print them off. If not, that's okay too. You're just going to have to take it by hand by note. So that's the kind of cruddy part about this, just because there's a lot that goes into this, and it would be nice to kind of have those graphs already built for you. But if you have graph paper at home, these will be easy to make. If you don't have graph paper at home, that's a-okay. You can still use lined paper. You're just going to have to create your own graphs. So we're going to start by graphing this parent function y equals x squared. So this is the parent function for a quadratic. This creates a parabola, which we've talked about before. So you're going to see that when we actually start to graph this. So whenever we're graphing things, we usually like to look at a table of values just to kind of help us create that function on our graph itself. So when I create my table of values, basically what I'm doing is, if you can see over here on the left side of this table, I have all my x values. And then on the right side, I have something that says f of x. This is basically just another name for y, which you guys should have already kind of been comfortable with. You've seen that in other classes. So what I'm going to be doing is taking this -2 and I'm going to plug it into my parent function. So I'm going to take -2 and I'm going to do -2 squared, and that would give me the value of 4. So 4 is my f of x value. That's my y value here. And then I can do the same thing for -1. And I'll get 1, because -1 squared is 1. And then same thing for 0. 0 squared is 0. And 1 squared is 1. And 2 squared is 4. So I have my x values, I have my y values. I can go ahead and graph those. And then I want to talk about what happens when we graph this and what we notice about those y values. So if I come over here to my graph, I have provided you a really nice graph, but like I said, if you can't print off the notes, you're just going to have to do this by hand, which is super unfortunate, but we will get through together. So I'm going to start with that -2, 4. So I'm going to come over to -2 and then up to 4. So -2, positive 1, 2, 3, 4, and I'm going to put my point. Then I'm going to graph the next point, which is -1, positive 1. So I'm going to go over 1 and up to positive 1 and graph my point. And then we have 0, 0, which is that origin value. And then 1, 1, and +2, 4. And then I'm going to draw my nice pretty parabola, which looks like a U shape. Oop, that was not very good. So let's try that again. And parabolas go up on the end. They go up to infinity. So we're just going to put some arrows on the ends of my parabola there. So what you can kind of notice from this is that it makes that nice U form. And what else you can notice is that if you look at my x and y values, they kind of repeat each other. So I have this -2, 4, and then down here I have 2, 4. And then I have -1, 1, and I have 1, 1. And you can see that on the graph. So my -2, 4 and my +2, 4 are right here. And then my -1, 1 and my +1, 1 are here. So the nice thing about parabolas is you're going to learn that they have this thing called they're symmetrical. So they have an axis of symmetry. So they are symmetrical about the y-axis, which means I could take my paper and fold it along that y-axis on this particular graph, and my lines from my parabola should match up. So that's what it means to be symmetrical. One side is the exact same as the other. So all quadratic functions are symmetrical. And then we need to get into talking about the domain and the range. So domain refers to my x values. I don't know that we've talked about this yet. So domain refers to my x values, and range refers to my y values. So what I'm wanting to know is, if I look at my graph, what are my x values that this graph will hit? So where is this parabola going to touch? What x values is this going to touch? So since I said that these parabolas go on forever, that means that they're constantly going to be expanding upwards, but they're also expanding outwards. So they're getting taller and fatter at the same time. I am doing hand motions, and I wish that you guys could see them, just because that helps to explain domain and range. But just think of this thing as going up and up and up and up and up, and as it goes up, it continues to get wider and wider and wider. So the domain for all parabolas, all quadratic functions, is all real numbers, or you can write the fancy R, which tells me that it's all real numbers. Now I said range refers to my y values, so I want to know what y values is this function going to be hitting. So if I look at my parabola, when we talk about domain and range, we always talk about going from negative infinity to positive infinity. So when I was talking about those x values, that means that my x values are going to hit every number from negative infinity to positive infinity. So when I look at my y values, I start down here at negative infinity, and I come up my graph, and I see where my values start to become real. So that's right here at this point. So at 0, 0, that's when I actually start to have y values. So my first point where my range happens is at 0. So we have a couple different ways that we can write this. One of those is we can write that y values are greater than or equal to 0. So what that tells me is that every number that's bigger than 0 is going to have a y value. So all my y values bigger than 0 exist. Another way that we can write this is we can write a closed bracket. So that tells me that 0 is included in this range. And I can say close bracket from 0 to infinity. And then I leave that open because open brackets signify that that number is not included. So infinity isn't a number that we can physically touch. We can touch the number 1, we can touch the number 2, but we can't touch infinity. So that's why we get this closed bracket versus open bracket. So you can write it those two different ways. I'm probably going to stick with this way just because that's kind of how our book goes by when we talk about domain and range. So if we looked at our graph again, what that tells me is that starting at 0, I have y values from 0 all the way up to infinity, because that graph keeps getting taller and taller and taller and taller, and it's going to just keep on going. So far, so good. We're not going to do too much today. I basically just want to go over some of the significant parts of a parabola and a quadratic function so that you guys can identify those to be able to graph them a little bit easier on your own. So the form that we use when we're talking, the form that we're going to use, there's multiple forms. Just like when we were doing linear equations, we had slope-intercept form, we had point-slope form, and we had standard form. We're only going to talk about standard form for quadratics, and that is what you have seen so far in all of our notes. It's where that y equals ax squared plus bx plus c. So that's the regular form of a quadratic that you guys have seen so far. So what I want to do now is identify some key features. So we're talking about the function negative 2x squared minus 4x plus 6. So I can identify my a, b, and c values. So here's my a, here's my b, and here's my c. So without knowing any more information, I can look at this nice graph here, and I can identify the vertex, the axis of symmetry, the x-intercept, and the y-intercepts. So what I'm talking about when I say the vertex is that's the highest or the lowest point on the graph. That's the point where that axis of symmetry is going to start. So for us, it's this value right here, which happens to be -1, 8. So when we talk about the vertex, we talk about that as a point. So we're talking about the point -1, +8. That is the very top of my graph. And when we go to graph these, that's usually the first point that we're going to graph because it's the easiest point to find. The next thing we're going to talk about is this axis of symmetry. So remember I said that quadratics were symmetrical, meaning I could fold my paper in half along that axis of symmetry, and whatever on the right is going to match whatever is on the left. So the axis of symmetry starts where the vertex is. So my axis of symmetry runs along this -1 line. And if I folded my paper along this line, I would create the same thing on the right as on the left. But since the axis of symmetry is a line, we need to write it as if it's a line. So this means that we need to write it like x equals -1. That is that pink line there. That is the line x equals -1. And whenever we write our axis of symmetry, it's always going to correspond to that vertex point. If you notice, my x value in my vertex was -1, and my axis of symmetry is -1. And it's always your x value. So then the next thing that we need to talk about is this y-intercept. So we should be pretty familiar with y-intercepts by now. That's just where the graph is crossing the y-axis. So that's where it's crossing the y-axis. So if we come over here and we look, our y-axis here is in black, and it's crossing right here at this point. So this point is called 0, 6. And your y-intercept is always going to be set up that way. Your x value would be 0, and your y-intercept is, if you look up here, whatever this c value is. They are always going to correspond. So your y-intercept is always going to be made up of 0 and whatever your c value is. And we're going to talk about that a little bit more later. But that's just something to notice right now. You don't really need to know that it corresponds to the c value. For these first couple, you're just going to be able to identify them from looking at the graph. And this is the point where that crosses the y-axis. The last thing that we need to talk about is our x-intercepts. And this is what we've been solving for the entire time that we've been doing quadratics so far. We've been trying to figure out where it crosses the x-axis. So you guys should be able to factor these or use the quadratic formula to find these. But just looking at the graph, we can identify those points as well. That happens at -3 and at +1. So my x-intercepts are at -3, 0 and at 1, 0. So if you look at that comparison between the y-intercepts and the x-intercepts, for the y-intercepts, I only have a y value, and for the x-intercepts, I only have an x value, which makes sense because we're looking for where they're crossing those specific points. So here's where I'm going to start to get into a little bit more of the language. So if my a value is positive, then my graph is going to open upward. So if my a value is positive, then I'm going to have a graph that looks like this. If my a value is negative, then the graph is going to open downward, meaning my graph is going to look something like this. So if I take a minute to go back up to this that I was just looking at, and I look at my a value, here's my a value, it's -2. My graph is opening down. So far so good, we're following the rules. So all quadratic equations have a vertex. So we just talked about that, which is the turning point of the graph. So the vertex is that turning point of the graph. And quadratic graphs are symmetrical across the axis of symmetry. Which runs through the vertex. So all quadratic equations have a vertex, and that vertex tells us where the axis of symmetry is. So we found that vertex, it's there in purple, and then my axis of symmetry was that pink line again. And there's a formula for finding this, and that formula is negative b over 2 times a. So we're going to use that formula eventually to identify these without having to, so that we can go ahead and graph them. So we're just going to remember that formula. This is going to come back for us, so we need to know this. All right, so a quadratic function crosses the y-axis at the c value. So we talked about that up above. I told you that that y-intercept matched that c value. The y-intercept always has an x value of 0. So for a parabola, the y-intercept will be the point 0 and then whatever my c value is. Oh no, this part got cut out of my box. Oops. A quadratic function crosses or touches the x-axis. This really got messed up. I'm so sorry. This should have been a little bit better. I don't really know what happened, but I'll go ahead and do it anyway. A quadratic function crosses or touches the x-axis twice, once, well, I guess it touches 2, 1, or no times. So it's either gonna cross the x-axis twice, it's gonna tap it once, or it's never gonna cross the x-axis, which I've already showed you that when we were going through kind of finding those x values, just when we were simply solving the quadratic equations. So I have this first example here, and we're gonna talk about this graph over here on the right, and we're gonna identify the y-intercept, the x-intercepts, the vertex, the domain, the range, and the axis of symmetry. So let's start by identifying the y-intercept, which is a little bit hard to see here, but that's okay. We're going to go ahead and use our best judgment. That's going to be this point right here. So that looks like it is 0 and then 1, 2, 3, 4, 5, 6, 7, 8. So our y-intercept here is 0, 8. Oops. And then we're going to identify what is the vertex. So we're going to come down here and we're going to find our lowest point, our turning point of the graph, and that's this point right here, which happens to be positive 1, 2, 3, negative 1. So 3, negative 1 is our vertex. Remember, I said that the axis of symmetry was whatever the x value of the vertex was. So our axis of symmetry is going to be x equals 3. So if we come back over to the graph, that's going to be this line right here, if I can draw it. Oops. And then keep coming up. Sorry, it's hard to draw in this little box. So that orange line is going to be our axis of symmetry for this quadratic function. The next thing that we're going to identify is our x-intercepts. So where is this crossing the x-axis? So that happens here and here, which is the point 2, 0, and 4, 0. And then we need to talk about the domain. So if you remember, I said that the domain of all quadratic functions is always the same, and that is that it's all real numbers. So it's going to cross every single x value. I'm going to touch every x value here. And then my range depends on where my vertex is. So I need to identify that again. So that's at 3, negative 1. So it's going to start at negative 1, and it's going to end at infinity. So we're going to start at negative 1, and then I'm going to touch every single y value from negative 1 all the way up to positive infinity. So that's these guys for you. That was your first practice. I think you guys should be able to easily do the next couple. So I have 2 problems down below that I need you to complete. here's the first, here is the second, and I will also, like I said, link this in the assignments tab so that you guys can do them on your own as well.